So I'm going to go ahead and write this question down over here. 2x plus 6 over x minus 2. There's nothing to be done over here because, well, I've got x minus 1 over, okay, open 2 brackets. Thank you. Hi, Zanobisha. Thank you. Murila's like, why did you delete your house room? I don't know where my house room is. I need to make sure I know what that means. Murila, you have to like elaborate. You have to explain a little bit more for me. Does anybody have how to like the factorization of these two trinomials for me? Thank you, Siam Tanda. Thank you. Hasna says 7 and 2. That's not enough, Hasna. I want both of the brackets for me. Oh, I see, Mirilla, like, oh, she meant above. Sorry, she made a joke and she misspelled it. Okay, hi, Mpo. Brayden, that's exactly what I was looking for. I want Mpo to finish this one up for me because she's amazing. She's already got the answers and everything. She or he, I'm not 100% sure. Mpo, do you want to unmute for me and finish up this question with me?
Ma'am?
Hello, my sweetie.
I thought you wanted the answer for the factorization. That's why I said that I had the answer.
Okay. Don't go away. Don't go away. Just because you factorized for me doesn't mean we're going to finish the question together, Mpo. Don't worry. Okay, so now, yes.
I'm not Mpo, I'm Kiaurata. This is my mother's thing.
Is it? Okay, so your name is Kiaurata.
Yes,
how are you? We're going to change your name for you. It's not even that deep. Don't worry. Okay. No worries. Give me a second. Let me change it for you. Kiaurata.
It's changed already.
Oh, see, teacher Cat, what would I do without you? Excellent. All right. Gift says, ma'am, can't you factorize the 2x plus 6? Yes, we can. And Gift, there's a reason why I'm not going to for now. Okay. Because I'm still going to add other things to it. But you can factorize it if you need to. There's an HCF of 2 that comes out of there. Okay. All right. So, Kiorata, let's talk about my LCD. Okay. What is my LCD going to be between these two?
It's going to be x minus 2, x minus 7.
That's it. Oh, so beautifully done. Thank you. Excellent. That's exactly what I was looking for. So I know that I want my LCDs to look the same on both sides. So I know I've got let me fix my brackets. Okay, x minus 2, there we go. And x minus 7 is equal to, all of this is over something, is equal to, on this side, I'm also going to get x minus 2, x minus 7, because the order doesn't matter. All right, let's talk about what's happening on the left-hand side. Okay, I've got x minus 2. What's missing from my denominator?
It's x minus 7.
Good. And if I put x minus 7 at the bottom, what am I going to have to do to the top?
You have to also multiply by x minus 7 at the top.
Exactly. I couldn't have said it better myself. That's it. X minus 7 as well. Okay, good. So on the top over here, I've got x minus 7. Let's do that better. X minus 7 multiplied by 2x plus 6. And all of this is equal to what's missing on my right-hand side. Is there anything missing?
It's nothing, ma'am.
Nothing. Good. So I can just write x minus 1. Okay.
Yes,
so that's not going to change. So Kiorata, as soon as my denominators look the same in an equation, what do I know I can do with my denominators?
Firstly, you have to multiply the 2 brackets to simplify them first.
Good. Okay. But before I go there, Kiorata, what I can do is, because my denominators look the same, I can cancel them. I don't need them anymore. I can cancel them. Okay.
Yes,
I don't really need them. So I'm just going to work with the top, and you're 100% correct. We're going to multiply the brackets on the right-hand side, right? So on the left-hand side. So I'm going to do FOIL here. Can you give me what my answer is going to be?
Must I do it first here or what?
Let's do it together. What's x times 2x?
X times 2x is 2x to the power of 2.
Excellent. And then x times 6?
X times 6 is negative 6x.
Oh, it's going to be positive because there's a positive in front of my 6 there. You see?
Oh, I thought you said x times negative 6. Okay, yes, ma'am.
No. Now I'm going to say I've got -7 times 2x. How much is that going to give me?
7 times 2, it's going to be -14x. Am I right?
Yes, absolutely, 100%. And then I've got -7 times +6. How much is that going to give me?
-42.
That's it, -42. Excellent. All right, I'm going to move over a little bit because I need the space. Okay, this is what we got. And then I know that on the other side of my equal sign, there's an equal to x minus 1. All right, now let's solve for the rest of this. Okay, remember, I've got a quadratic. So what do I need to do what do I need to get on the right-hand side?
On the right, what's my right? I have to get all my constants on my right-hand side.
Oh, not in the case where we have a squared. I can bring all of this stuff over the side and I can put it in standard form. Do you remember what standard form means? What should I have on my right-hand side?
I think maybe you should tell me. Maybe I forgot.
Okay.
But
all right.
I think I have to have 0 on the other side.
Yes, absolutely. That's it. I need to get 0 on my right-hand side. So what's going to happen to everything? -1.
I'm gonna add x and add 1 on my left-hand side.
That's it. Excellent. Good. So I'm going to end up with 2x squared, and I'm just going to add like terms quickly. Okay, I'm going to get 6x minus 14x is going to give me -8x. And then what's going to happen to this x when it comes over to the side? It's going to become minus 1. Yeah, now I'm lying. Okay, so 6x minus 14x will give me -8x, and then this x will come over and become -x, right?
Yes.
So -8x minus x will give me?
-9x.
Excellent, good. And then my 1 over here, I'm going to get 42, and this 1 is going to come over to the side and it's going to become +1. So -2 minus 40. Yeah, -42 plus 1 will give me?
-41.
-41, excellent, is equal to 0. Okay. All right, so do you know anything that's going to happen from this point on?
I think now what I have to do is, let me see. I'm not factorizing, right?
Yes, you are. Of course you are. Look at what I have. I've got a squared. I've got a trinomial. Do you see that it's a trinomial?
Yes, ma'am.
So I have to factorize again. How would I factorize a trinomial?
You're going to first look for the highest common factor, which is not there.
Mm-hmm.
And then I have to then make, what is it called? Perfect squares, 2 brackets.
I have to put 2 brackets. Well, it's not going to be a perfect square. It's just a trinomial, but I'm going to tell you, Georata, we're not going to be able to factorize this. Okay. We're not going to be able to. But thank you so much for getting us to this point, because this is as far as we can go. Do you see how beautifully you did that? You even gave it to me step by step. Okay, we just need to remember the steps. Very well done.
Thank you, ma'am.
You're very welcome. Okay, all right. The reason why I'm saying we cannot factorize anymore, guys, is because my 41 over here, 41 it's a prime number. Okay, and there is no prime number that I'm going to get apart from 41 and 1. Those are my only 2 factors. And it doesn't matter what I do to either of them, none of them are ever going to get me to 9. It's not going to, none of them are going to get me to -9. It's not going to happen. Okay, so at this point, especially in grade 10, you can stop this question right here, and we can say, cannot factorize. That's all we're going to say. Cannot factorize. Okay, now I'm going to tell you guys now, there is a way to factorize this. There is. It's called a quadratic formula, but you don't learn about the quadratic formula until, okay, we don't learn about the quadratic formula until grade 11. Okay, so that's why I'm saying if you come across a question like this, where you cannot factorize in grade 10, you are more than happy to write, I cannot factorize further. And you leave the question right there. So we're not going to be able to find any solutions or any whole or integer solutions for this particular question. Okay. So this is as far as it's going to go for us. Yeah, I hope that makes sense. We're not going to be able to get anywhere further than this. All right. Siamtanda, what's up, my sweetie? I see Siamtanda's hand is up. Hello.
Hi, ma'am.
Hello, my sweetie. What's up?
I'm so lost. I was lost on the first question, on the second part, and I don't know.
Okay. All right, my sweetie. Listen. So the questions that we're doing now, they are actually revision. Okay. We've done like millions and millions of them before. All right. Let me just see if I've added another one here. No. Okay. I've added this one. Okay. So we're going to go through this one. Okay. And I want you to take it step by step with me.
Oh, no, ma'am.
It's okay. I'm right here. I'm not going to leave you. I'm right here. Okay. Don't stress. Okay. Take a deep breath in. Deep breath.
Okay.
Okay. Good. Now, this is a recap. Like I'm saying, we've done this before. What is the first thing I'm going to do over here? What's the first thing we always do?
Okay. We'll factorize.
That's it. We're factorizing. Good. All right. Is there any reason for me to factorize x minus 5?
No.
Good. Is there any reason to factorize x?
No.
Okay. What about x squared minus 5x?
I don't think you can. Can you?
Have a look again. Do they have anything in common? Where do we start when we factorize?
Oh, yes.
What can we take out as a common factor?
X.
Good, we can take x out. I'm going to do it over here on the side. Okay. So I'm going to take x out as a common factor. What am I going to have left?
X minus 5.
That's it, x minus 5. Excellent. All right, I'm going to rewrite this. Okay, I'm going to go 4 over x minus 5 minus 10 over x is equal to, and now I'm going to put the nice part that we just factorized over the x over minus 5. All right. Now, what is the next thing we need to look for?
Common. Oh, LCM. Okay.
Or an LCD in this case. The lowest common denominator, right? Do you see a lowest common denominator here for me?
Hey, man. I don't know.
Okay. Remember, Siamtanda, when we had things like a half plus like a third. What would my denominator be over here? What would my lowest common denominator be?
6.
Good, because we took 2 and we multiplied it by 3, right?
Yes.
Good. So now what we're going to do is we're going to look at what we need to multiply by each other in order to get that. Now, look over here. I have an x and I need to multiply that x with x minus 5, correct?
Yes.
So that I can get a common denominator. So my LCD is going to look like x multiplied by x minus 5. Is there anything else? Look at this. Does that look familiar?
Yes.
Where is it? It's my LCD, right?
Yes.
So do I need to add anything more to my LCD?
No.
No, I don't need to because it's all already there. You see it?
Yeah.
Okay, excellent. Now comes the real work. Let's do the real work. I've got x minus 5 over here, but my LCD is actually x times x minus 5. What's missing from this LCD over here? What's missing?
X minus 5. X. Wait. What?
Missing.
Okay, we're missing.
Okay, this is my denominator. That's my common denominator. I've got x times x minus 5. But over here, I've only got x minus 5. Let me rewrite it. Over here, I've only got x minus 5. So what's missing from my denominator over here?
X.
X, good. And what I do on the bottom?
I do at the top.
Good. So I'm also going to multiply my top by x. Yeah. So over here, I've actually got 4x over x times x minus 5. Let's do the next part.
Okay.
Minus, and then I know I've already got a 10 on the top. Let's look at this over here. My denominator is x times x minus 5. I've only got x. What's missing from this denominator? Here's my full denominator, x times x minus 5. I've only got
Okay.
the x.
Okay,
What's missing?
x minus 5.
Good, x minus 5. If I do it to the bottom, I need to
Do that at the top.
good. I need to do it at the top as well. Hello, Titan. I see Titan just joined us. So I'm going to take this negative 10 and I'm going to multiply it by x minus 5. Okay. And all of this is equal to, I've got 2 on the top over here, all over x times x minus 5. All right. So this is my denominator. My denominator is x times x minus 5. And over here, my denominator is also x times x minus 5. Is anything missing from my denominator over there?
No,
No. So do I need to do anything to the top?
no.
No. Good. Nothing. So I'm going to leave it exactly like that. Okay. All right. So now that all my denominators look the same, Siamtanda, what can I do?
Work it out.
Yes, I can, but I can drop my denominator as well. I don't need it. Okay. I don't need my denominator anymore. Okay. So my equation then becomes 4x, and then I need to distribute this negative 10 in. So I'm going to get negative 10 times x and negative 10 times negative 5. Can you do that for me? Negative 10 times x would give me?
Negative 10x.
Good, negative 10x. And then negative 10 times negative 5?
Negative 50.
Oh, not negative 50, negative 10 times negative 5?
Oh, 50.
Plus 50, good. Plus 50 is equal to 2. I don't even need my denominator anymore. Okay, now look at what I've written, Siamtanda. Is this easy to solve for?
I can't really see it. There's like, can you move
Okay,
it to the side a little bit?
I'm gonna move it a little bit to the middle. Okay, we're working on this part over here. 4x minus 10x plus 50 is equal to 2. Can we solve for this?
Yeah.
This is easy, right? It's a standard linear equation.
Yeah.
So everything with an x will stay and everything without an x will go to the right-hand side. So what's 4x minus 10x?
6 minus 6x.
Good, negative 6x, good, is equal to. I'm going to take this 50 and I'm going to take it over to the other side and it's going to become negative 50. So I've got 2 minus 50. How much is that?
Negative 48.
Negative 48. Good. How do I solve for x here?
Negative 6x divided by negative 6x.
Good. So I'm going to divide by negative 6 on both sides. And therefore,
therefore x equals negative, where I can't see.
Sure. Okay. Okay. It's I think if you're on your like phone screen, you're either going to have to zoom in or zoom out. I'm not sure which one.
I'm on the laptop, so I don't know.
Sure. And you can't see what's happening on my screen right now.
I can see what's happening on the screen. It's just that on the side, there's like.
Oh, okay. So this, okay, you're going to have to like move to the left or to the right. Oh my goodness. Okay. This is getting complicated. Can you see it now? I need negative 48 divided by negative 6.
Okay, I can see it now.
Yeah. Negative 48 divided by negative 6 will give me?
Let me just open it up.
We should be able to do this. Company was still using our calculators. Therefore, x is equal to?
48 divided by 6.
That's it. Thank you, Teacher Kat. I was about to mention that. A negative and a negative will give us a positive answer. 48 divided by 6 will give us?
Positive 8.
Positive 8. There we go.
Okay, I see now. I get it.
It's not that complicated. Remember the steps, my sweetie. Okay.
Okay, thank you.
Remember the steps. Okay. Now, I know somebody. Thank you, Siamtanda. You did that. Wow. I want to hear your voice again soon. Okay.
Okay, man.
All right. Excellent. Now, I see a lot of you guys being like, isn't it negative 50? No, guys, it's not. Remember, we spoke about how if there's a negative here, this negative belongs to this number. So this number was actually negative 10. And if I've got a negative 5, negative 10 times negative 5 is going to give me positive 50. Okay, so I need you guys to remember that and not just be like, no, ma'am, it's not 10, it's negative 10. And that's why I keep saying negative 10 times negative 5. Okay. Thank you, Tembile. Babala says, ma'am, is it possible for the equation not to have a lowest common denominator? Yes and no. Okay, because if, let's say, for instance, Babala, my question says 2 over x is equal to 3 over x minus 3. My lowest common denominator is x times x minus 3. I need to multiply them both. So they will always be a lowest common denominator because we will make one. Okay, so it doesn't matter how we write it. Okay, I saw somebody else. I saw somebody else say, ma'am, when are we doing simultaneous equations? Now, we're doing them now. We're doing them right now. Okay, but before we get to that, if we have anyone new, can I ask you guys to just type in the chat, hi, I'm new, or you can raise your hand so we can give you a nice big fat Watobe welcome. Okay. Hasna says, ma'am, don't the x minus 5 and x minus 5 cancel? No, Hasna, because remember, the only way I can cancel is if I have something common on the top and on the bottom. But in that other question, both my x minus 5s were on the bottom. Okay, they were on the bottom. Okay, so I can't cancel. All right. Oh, there we go. We've got a couple of new people. We've got Lesedi, who's Lesedi. Really? I don't trust this Lesedi. Katlego is new. Katlego, welcome. Ketiwe is new, joining us for the first time, and Onika as well. Welcome, everybody.
Welcome.
Michael literally is part of the furniture. He's the couch we sit on, and I'm new. Make it make sense, Michael. Welcome, everyone. It's so great to have you with us. Thank you, Kioratile, for making them feel welcome. You guys are doing. Sisha says, ma'am, isn't the 6 supposed to be positive when it goes, or negative 6 supposed to be positive 6 when it goes to the other side? Yes, Sisha, but we didn't have to take it to the other side because it wasn't 6, it was actually 6x. Okay, so we didn't have to take it to the other side. All right. Akwando, I don't know what the big belly dude is for, but thank you for making everybody feel welcome. Okay. Hi, Nyasha. Hello, Nyasha. Oh no, Nyasha's gone. All right. Okay, guys. So we're going to be talking about simultaneous equations. Nyasha, whenever you're ready, you can unmute for me and ask your question, my sweetie. All right. So I know that for those of you who were here last week, Wednesday, you started these with teacher Jen, and she taught you guys about doing, she's still here. I just need you to unmute for me, my sweetie. Okay. I need you to unmute when you have the chance. Okay, we are doing substitution and elimination. I'm not sure how far she got, but we're going to be talking about substitution again, and we're going to use the same example. I want to make sure that we're all on the same side. Now, just a show of hands, you can put a thumbs up or a thumbs down in the chat. How many of you guys have already done simultaneous equations at school? That's okay, Brayden. We're going to go through it right now. Brayden's like, nah, ma'am, I didn't. Okay, that's okay. We're going to work through it. Don't stress. Marula already did it. Hasna hasn't done it yet. Courtney has not. Ketiwe has not. So many of you guys have not done it. Anati hasn't done it. That's okay, guys. We're going to take it step by step. Zanoguche hasn't done it either. Zamanzini says not yet. See, this is what's confusing me, guys. This is what's confusing me. You guys are already moving on to trigonometry and your teachers haven't done simultaneous equations. Fishy, because you can't do trigonometry first. You must do this and literal equations. And I'm like, some things, the math is not mathing. It's not mathing. Yeah. See, teacher Kat, you and me, we both, I'm just like, no. You, I don't know how any grade 10 student can do 10 things. I know, Hasna, sometimes it happens, and that's why we're here. Okay, we're here to help. Okay, it's not. And somebody's like, this equation seems a bit off. Okay, and you might be right. Okay, let's talk about what this actually means, guys. Does anybody know, who can tell me, what does simultaneous mean? Does anybody know what the word simultaneous means? We don't, Ketiwe, but I can tell you now, if we get AP math classes, I'm putting my hand up to teach AP math. If we get it. Okay, one after the other, or yes, actually one after the other, or we can say simultaneous means at the same time. Okay, at the same time. Michael, your school, your school. Okay, it means at the same time. Good, Katiso, that's exactly what I was looking for. Okay, simultaneous means at the same time. Okay, we can also say something like one after the other. It's correct. Mulisa, I don't know how that's even possible. Okay, I'm so glad. Wikuka's just gonna be firing all the answers because Wikuka's school is like done, and you guys are like lagging behind. All right, so we're gonna learn how to start solving for this at the same time. Okay, I want you guys to look at this first equation over here. If I say to you guys, give me an answer for y, tell me, therefore y is equal to. Are you able to do this? No problem, Buntuzu. Ubuntu. Oh, hi, Buntu. No worries. Okay. Can you guys give me an answer for y here? Yes or no? Katisa's like, no. No, ma'am, no. No, we can't. Okay, we can't find the answer for y because we don't know what x is. And that makes this very difficult. Okay, same with if I asked you guys, please give me an answer for x. Therefore, x is equal something. But we can't because we don't know what y is. And you're right, Kioratile, we'd have to substitute somewhere. But we don't even know what x is. And we don't even know what y is. So what we're going to do is we're going to look for, or we're going to try to solve for x and y at the same time. Substitute for it. And Mirula and Akwando are completely ruining the lesson because they jumped the gun like 6 million times ahead of the time. Okay, we're going to get there. We're going to get there. All right, so we're going to be learning about substitution, guys. So I'm going to take these two things and I'm going to make sure that I can solve for them as we're going. That's okay, Mirula. That just shows me that you understand and you're with me. All right. Now, I want us to learn how to write these things properly. Okay. We need to learn how to write this in a particular way so that our teachers understand what we're saying. Because maths is a language. It's a language. All right. So the first thing I'm going to do is I'm going to write here, let, and I hope you guys are writing along with me. I'm not writing by myself. Everyone is with me here. I'm going to write here, let y is equal to x plus 4. That was my first equation. And I'm going to do this. I'm going to go dot, 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 1. I'm going to name this 1. And what that actually means is that I'm labeling this equation 1. Okay. And y is equal to negative 2x plus 1. And I'm going to go dot, 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 2. Okay. I'm labeling them. I've labeled the first one, equation 1, and I've labeled the second one, equation 2. And the reason I do this is so that when I do what's next, my teacher understands what I've done. Okay, so my next step is I'm going to write this. I'm going to go sub, which stands for substitute. Substitute equation 1. Do you see how I'm writing them exactly the same? There's a 1. Okay, there's a 1 there, and then there's a 1 over there. Okay, Mihasna says, ma'am, where did you get the negative 2? Here, this is where the negative 2 comes from. Negative 2x. Okay, it was in the equation. I hope we didn't miss it. Okay, it was right there. Okay, all right, so I'm going to sub equation 1 into equation 2. And Michael says, in your opinion, ma'am, which one is better? They both have their merit, Michael. Yes, you can. Brandon, you can say sub EQ1 if you want to write it that way. Actually, I kind of like that. Sub EQ, because EQ stands for equation 1 into equation 2. Okay, you can do that. You can do that. Okay, you can do that. Michael, when you say which one is better, I'll show you why sometimes we use the one instead of the other. Okay, I'll show you why. It gets a little bit more complicated as we go along. Okay. Okay, so now what I'm going to do, guys, is I'm going to go and I'm going to do this. I'm going to say this is y. You guys see how this is y. This is a y. And if I'm going to sub equation 1 into equation 2, I'm going to make sure that in the equation 2, wherever I see a y, I'm going to replace my y with x plus 4. So I'm going to look at equation 2, and wherever I see a y value, I'm going to replace it with x plus 4. And you guys see how I have a y over here in my equation 2. I have a y there. So I'm going to take that y, and instead of writing y in my next line, I'm going to replace that y with x plus 4. Okay, so I'm going to go x plus 4, because that's where my y was sitting. And this x plus 4 is now equal to negative 2x plus 1. That's it, Inganati. Wow. Oh, beautiful. You know me, guys, I speak very fake Italian because it sounds so nice. I want to say arrivederci. I don't even think arrivederci is Italian, but I want to say it because it sounds proper. It sounds like something I should be saying. Okay, I need to learn how to say it. Molto bene. Oh, yeah, just excellent. Perfecto. There we go. Teacher Cap's like, Teacher Coco, stop. All right, okay. I'm stopping. Me and my cheesiness, we're stopping. All right, guys. So if I look at this equation, let's look at this equation that I've written over here. X plus 4 is equal to negative 2x plus 1. Can I solve for x here? This is nice and easy. I can solve for x. Can you guys solve for x for me? While everybody in the chat's busy laughing at me. Thank you, Ntokozo, for focusing on the word. Guys, please solve for x for me. Tell me what is x. Remember, everything with an x to the left, everything without an x to the right. Easy stuff. Yes, Leah Bona. Hello, Leah Bona.
Hello, ma'am. We can solve for.
Yes, solve for x for me, my dude.
We first group like terms, which is x plus 2x.
Good. I'm going to take x plus 2x equal to
is equal to 1 minus 4.
Good. The 4 goes over and it becomes minus 4. Excellent. Solve this for me. X plus 2x.
It will be 3x.
Good. 3x is equal to 1 minus 4 is?
It's minus 3.
Excellent. I'm not done. I still need to solve for x, so I'm going to divide both sides by 3. Good. Therefore,
x is equal to minus 1.
Excellent. Minus 1, because negative 3 divided by 3 will give me negative 1. Don't go away. Don't go away, Leah Bona. I want you right here. Are we done?
Yes, ma'am. We are done.
Oh, no. Remember, we're solving for 2 things. We've only solved for x. What do we still need to solve for?
We need to solve for y.
Yes, that's it. We need to solve for y. Excellent. Now that we've got an answer for x, we can take it and we can substitute it into our formula. You see how much easier it is? I'm going to sub into this formula, into formula 1. Okay, is that okay? Can we do that?
Yes.
Okay, good. So I'm going to go y is equal to, what was my value for x again?
X is minus 1.
Good. So I'm going to replace x with minus 1. Okay, so I'm going to go minus 1. Finish up for me, Leah Bona. Minus 1.
Plus 4.
That's it. Therefore, y is equal to?
Y is equal to 3.
That's it. Beautiful. Mwah, excellent. Very well done. And I'll tell you something, Leah Bona, what this actually has done, it's given us an x and a y coordinate on a Cartesian plane. So I've got an x value negative 1, semicolon 3. This is actually what it's done for me. Okay. And what this actually represents, guys, is this is a straight. Do you guys see how this is actually y is equal to mx plus c? This is y is equal to mx plus c, and this is y is equal to mx plus c. And what we've actually done is we've taken 2 lines and we found the part in the middle where they meet. Right where they cross, just like, bah. And now we know that the point here where they meet is -1 and 3. This is what we're actually doing. And you see, it's so easy. So easy. I know it sounds hard. Okay. Sithe says, ma'am, where did you get the -1 + 4? All right, Sithe, here's what we did. We took this equation 1 over here. All right, let me write it in red so you can see it. Okay. We took this equation 1 over here and we said y is equal to, and remember equation 1 is x plus 4. And if you look over here, do you see how our x, we just found our value for x. Our value for x was -1. So we took x and we replaced it with -1. Okay, does that make sense? Does that make sense? That's where we got that from. So I hope that's making sense. All right, let's talk about elimination. Let's talk about elimination. Excellent. Now, what we're going to do with elimination, guys. I was like, my teachers didn't show us. Okay, it's okay, guys. Now we know how to do it. All right. When we look at elimination, we're going to do the exact same thing. Okay. Remember, guys, we need to tell our teachers what we're doing. So we're going to go let. And then we're going to start equation 1. Y is equal to x plus 4 ... equation 1. And then we're going to go y is equal to -2x plus 1 ... equation 2. We're going to do the exact same thing. However, there are some rules that we need to look for when we're doing elimination. Okay. We're going to subtract. That's it, Kioratile. We're going to subtract. But here's what I need you guys to do for me first. I need you guys to make sure that when you write the two equations, y is sitting right underneath y. Your x's are sitting right underneath each other. And your numbers are sitting right underneath each other. Okay, I need to make sure that they are right underneath each other. True. Okay, David says, I'm going to do substitution because our teacher says it'll make our life easier. And she's correct. She is, in this case, she's correct. But I'm going to show you a part where substitution is going to start like, you're going to be like, ma'am, why? Why? You're definitely going to use substitution in grade 11 when you do quadratic equations and you need to solve for x and y. Yes, you're going to use substitution. But for now, I'll show you where elimination is going to be a little bit easier. All right, so here's what we're going to do. Remember, we've got equation 1 and equation 2. I'm then going to write, here's my instruction that my teacher needs to read. I'm going to go equation 1 minus equation 2. Okay, equation 1 minus equation 2. So now I'm going to go old school. Remember when we were in grade 1 and grade 2 and they taught us how to minus? They were like, put one number on the top and one number at the bottom, the units and the tens and the hundreds. That's why we need our y's and our x's and our numbers right underneath each other. Okay, so that when I minus like this, I'm going to go y minus y. I'm minusing them right underneath each other. Okay, somebody's like, ma'am, please scroll down. Okay, I'm going to scroll down a little bit. I hope that's helpful, Tabsile. Okay, so y minus y. So guys, tell me, okay, what is y minus y? Tell me in the chat. Y minus y is? What do we get? Y minus y. Good. Oh, I can't see. It's 0. Good. So I'm going to get 0. Actually, let me rewrite this whole thing. Otherwise, it's just going to get very complicated. Y is equal to x plus 4. And y is equal to negative 2x. I want to make sure everything is right underneath each other. Okay. Imanga's like, why did maths go from numbers and numbers to alphabets? Okay. I will explain to you, Imanga, don't stress. Okay, so y minus y, guys, is going to give us 0. And then I've got here, okay, now I need you guys to follow with me here. I've actually got x minus -2. A minus and a negative are going to give me a, tell me in the chat, a minus and a minus are going to give me a positive, right? Because I've got minus -2, this is actually going to become x plus 2x. Do you guys understand? Give me a thumbs up if you understand why I'm actually plussing. Do you guys understand why I'm plussing? Kiaurata is lost. Okay, I knew this might happen. Okay, stop it right there. Okay, remember guys, remember, my equation says -2x, right? My equation says -2x. So I'm going to write this out. I'm going to write it out, guys. I've got x minus -2x. Okay. X minus -2x. A minus and a minus, what's that going to give me? It is. Imang is like, isn't that the sign change rule? It is the sign change rule. Okay. It's going to give me a positive. And that's why I'm adding. That is why I'm adding, because x minus -2 will give me x plus. Okay, excellent. I'm very glad we're getting it. Okay, and x minus -2 will give me x plus 2x. So what's x plus 2x, guys? X plus 2x will give me, that's it, Inganati, 3x. Okay. Good. And now watch what happens next, guys, because we're going to run into the same problem again. Have a look here. Now I've got 4 minus +1. So I'm going to write this out. 4 minus +1. This positive, this negative and this positive are going to give me a, what are they going to give me? They're going to give me a negative. Good. So I'm going to get 4 minus 1, what is my answer going to be there? 3. That's it, Inganati. It's going to give me 3. Okay, 3. So I've actually got over here, I've got 0 is equal to 3x. This is a positive 3. So this is 3x plus 3. Okay, this is what I have left. Can I solve for x from here? Is this easy for me to solve for x? This is easy. Solve for x for me, guys. What is x? I'm going to take my 3x over to the other side, and it's going to become -3x is equal to 3. I hope you guys saw how I did that. I took the 3x over to the other side of the equal sign. That's it, David. That's correct. Don't doubt yourself. Don't put a question mark on the end there. And then we could, don't forget to divide both sides by -3. Therefore, x is equal to -1. Zanugushe is like, ma'am, I am lost. Okay, Zanugushe, this is a very lengthy process. Okay, I'm going to need you to take a screenshot, and then I'm going to need you to go over it, okay, again, or rewatch this lesson. Okay. Yeah. Everybody's like, you see, substitution is so much better. I'm going to show you guys an example where you guys are going to be like, okay, maybe I'll eliminate. I'll show you guys. It becomes a little bit tricky. All right, now that I've got x, I can go back and solve for y, like we did with the other one. Okay, I'm going to use this equation. Y is equal to x plus 4 because I have a value for x. So I'm just going to substitute back. Y is equal to x plus 4. I can go y is equal to, my x value is -1 plus 4. Therefore, y is equal to 3. And again, we get the coordinates, -1 and 3. That's what Lissetti's like, life is nothing without a little challenge. I like it. I like it. All right. For those of you who are like, I prefer substitution. Okay. What happens when we have a question like this? And I'm just going to make it up. I'm going to make it up. Okay. I'm going to give you guys 2 equations. X over 2 plus y is equal to 7 over 3. That's my equation 1. And my equation 2 is x plus y over 4 is equal to 5 dot 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 2. Solve for x and y. Okay, all right. And you guys see, you're looking at it. Yes, Hasna, I'm making you choose elimination. Okay, and and the reason why, Marila's like, give me 2 minutes, I got this. Yeah, let me go. Let's go. Okay. This is not punishment, I promise, gift. I'm just kidding. I'm just kidding. All right, I'm going to explain to you guys. Hold on. I know everybody, I'm sure everybody, guys, if we were sitting in a class right now, everybody would be like, yo, ma'am. Ma'am, how could you do this to us, ma'am? Yo. No, okay. It's okay, guys. Okay. You see? I told you. I told you. All right. The reason why. Okay. No, teacher Kat, like, I don't know, I feel like allowing everyone to unmute and complain. Whoa. Okay, so this is why we would use elimination in a question like this. Okay, Mira's like, I got an answer, but it looks wrong. It's okay. Okay, in an equation like this, guys, what we have to do now is we're going to find LCDs, and we're going to have to make sure that the equation is same on every side and blah, blah, blah. And that makes it a lot more complicated. So in this case, what I would do is I would find the LCD over here, and my LCD would be 6, right? So what I would do is I would multiply straight through by 6. Okay, and I can hear Michael in a Japanese voice going, Nani? Yeah, I see you. Okay, yes, David's like 6 because I've got a denominator of 2 and a denominator of 3, and therefore my LCD is going to be 6. Okay, so if I multiply through by 6, over here I'm going to multiply by 3 because this part is missing 3. So this will become 3x. Tabisila says, why 6? Because of my LCD, not 8. Not 8, guys, because the LCD over here is 6. Okay, I don't want us to get confused. But we're going to do this kind of question. Thank you, Teacher Kat. It's the lowest common denominator between the two. Okay, we're going to do a question like this on Wednesday. Okay, so I don't want you guys to like get too bogged down on this. But I would have to multiply through by 6. And what I would end up getting for equation 1 is I would get something like 3x plus 6y is equal to 14. Right. And over here, I would get 4x plus y is equal to 20. All right. And I know where I got these numbers. I will explain it to you guys in the next lesson. Okay. In this case, then, it's going to become a lot easier. Let's just say, for instance, okay, I'm fixing the maths here. The maths should not look like this. Okay, it's going to be a lot easier, guys, for me to solve if I just go 3x minus 3x. 3x minus 3x, this part will give me 0, and then I can solve for y. Okay, but next lesson, we're going to get there. Yes, Ntokozo's like, in elimination, do you always minus the 2 equations? Yes, you do, because we're trying to eliminate the 1. Okay.
Not always.
No, oh, actually, no. No, you're right, because we could add, teacher.
Yeah.
Yeah, we could add or subtract. Okay, we're just trying to eliminate one of this. Kate is like, I did this in class. See, Kate, I'm not, guys, I know what I'm talking about. All right, I'm going to give you guys one example to pick to solve for. Here is your example. Okay. She's over 9,000. Okay, which is okay. Forget that question. I want you guys to solve for x and y simultaneously over here. Do number 1. Yonge says, are you going to give us a quiz? Quizzes are on Wednesday, Yonge. Okay, they're on Wednesday. I want you guys to try these ones. And remember, guys, we need to let our teachers know what we're doing. So we need to start by going, let y is equal to 3x plus 2 dot, 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 1. Okay. Esinako, let's say, for instance, Kiorata, I'm going to take a question just now. Esinako says, when do we know when to add or subtract? Esinako, when you have something like this, y is equal to 2x minus 1. And then over here, you have minus y is equal to x plus 3. Okay, so now if I minus over here, this is going to become a plus. So I can't minus. Okay, I can't minus. I need to add. Okay, I need to add. Because if I go y plus y or plus negative y, that will give me 0. Okay. So depending on what you have to do, then you can choose there. Oh, Melissa, fingers crossed. Okay, Kiaurata, what's up, my sweetie?
Ma'am,
Yes.
I was asking if like you were to give us this equation, are we gonna always have to substitute first before we eliminate? Is it gonna always be like that?
Yes, so you can choose. Kiaurata, they won't tell you which one you're looking for. Okay, they will just say solve for x and y simultaneously. They won't tell you substitution or elimination. Okay, they will just say solve for x and y. You can choose whether you want to substitute or whether you want to eliminate. Okay.
Okay, ma'am, thank you.
You're very welcome. Akuma says, are we getting any homework? Yes, you are. Yes, you are. Ketiwe says, ma'am, please move up. I'm not sure where I'm going to move up to. Braden just asked the question, said, ma'am, are we always going to add? It depends on what it is that we are solving for. Okay. If they are both positive, Ganati, I'm sorry. There's always that one teacher's pet who must always ask for homework. Okay. I know. I'm sorry, Imange. Guys, Mirula, since today. Okay, yes, Braden, it depends. So if let's say I have, Braden, if I have y and y, both of them are positive. So the only way to get 0 is if I minus. Okay, but Braden, if one of them is negative, if I have negative y and positive y, the only way I can get them to be 0 is if I add them. Negative y plus y will give me 0. Okay, so depending on which one it is, okay, depending on which one it is and how we want to get 0. Okay. I'm sorry, Shantini is also crying, guys. I'm sorry. All right. I'm sorry, Spostika. Spostika is like, Maraman, we just arrived. Spostika, come on. Spostika is like literally, she's the furniture that I work on when we're doing these questions. Yes, that's it, Braden, to cancel out the one or the other. Okay. Yes, Patu.
Hi, ma'am.
Hello, my sweetie. How are you doing?
I'm good. How are you?
I'm good, thank you.
Ma'am, I wanted to answer.
Yes, absolutely. I love that. Let's go.
Ma'am, I used substitution first.
Excellent. All right. So what did you write over here to show that we're substituting?
Way.
Here. So we've written y is equal to 1, right? That's equation 1 and equation 2. What must we write to show our teachers that we're actually substituting? What do we need to say? To say substitute.
Oh.
But it's very important so that your teacher knows exactly what it is you've done. Do you know why? Because,
Why?
for instance, I choose to make this one equation 2, and I make this one equation 1. Okay. My teacher needs to know which one I've put where. Okay.
Oh, okay.
Okay, so I need to make sure that I'm numbering them and I'm saying what I'm doing. Okay, so it's very important. So which one did you sub in where? Did you sub in the
first equation?
Okay, good. So we're going to write here sub equation 1 into equation 2. Okay, good. What was your next step?
3x plus 2 is equals to 2x plus 1.
Is equal to 2x plus 1. Good. And what did we get?
3x minus 2x is equal to 1 minus 2.
Good. 3x minus 2x is equal to 1 minus 2. Well done. And we got
Therefore, x is equal to negative 1.
x is equal to negative 1. I'm not done, Patu. What's missing?
The y.
Good. Let's solve for y. What would my y be? Y is equal to?
Is equal to 3 bracket negative 1 plus 2.
Excellent. I'm so glad you remembered. Plus 2. Good. Because we're multiplying. Good. Which is equal to?
Negative 1.
Good. Therefore, y is equal to negative 1. You skipped a couple steps. I'm happy with it. Okay. All right. You did that so beautifully. It shows that you understand, and I'm thrilled. Happy chap. Well done, Patu.
Thank you.
Excellent. All right, guys. I just need Teacher Kat to run the poll very quickly before everybody kills me for giving them homework. Guys, I mean, guys, it's one question. It's one question. One question. One question. Hey, I'm going to have to reevaluate. Okay. All right. It's just this one question, guys. You guys can use substitution or elimination. I know a lot of you guys love substitution. This one is fine with substitution. It's fine. Okay. It's not that bad. Oh, I see something's missing here. There should be a Y over here. One question is too much. Let's study. Oh my goodness, I'm snorting. Oh gosh, I miss when math had picture. Guys, it cannot be half a question, guys. I'm sorry. Okay, guys, it's not that bad, I promise. All right, I had so much fun with you guys today.